Okay, a question, the same question, June 18, variant 62. And we have another question on both normal and binomial. And then there is a question on normal approximation. Okay, so guys, it says in a certain country, 60% of mobile phones sold are made by company A. So I can say the probability for from A to B, this is zero point 0.6, okay? And then from company B, this is 0.35, and others, okay, this is going to be 0.05. Then it says find the probability that out of a random sample of 13 people who buy a mobile phone, fewer than chose a, like this is from company A. So we shall assume that now this is going to be a binomial distribution because we're given the number from which we are going. This is there are exactly 13 people and is talking about the company A. So this zero point 0.6 would be the probability of success. So we have n equal to 13, P equal to zero point 0.6 and Q equal to zero point 0.4. So we have divided the whole situation into two things, either company A or not by company A. That is a failure here. It says find the probability that fewer than 11 choose. So fewer than 11. So it says probability X is less than 11. Okay, less than 11. So it is up to you, like you can go from 11 to backward up to 0 here, or you can do 1 minus up to these people, like this area over here. Okay, so I think that is a better option here. We'll do it 1 minus the probability X equal to 11 plus the probability X equal to 12 and plus the probability X equal to 13. So after doing all this working, we get, okay, so we get 0.967 correct to three significant figures. Okay, so this was a question on the binomial distribution. If you look at the bottom of this page, there is another question of 5 marks. It says, use a suitable approximation. Let me clear all of this and move this to the top here. It says use a suitable approximation to find the probability that out of a random sample of 130, such a big number, so that is why you are using this suitable approximation, who buy a mobile phone, at least 50 chose a mobile phone made by company B. By the way, what was the probability of getting a phone from that was 0.35 if I am not wrong, Hannah? So this is now again, this is another, I'm not using X again because we have already used X in the previous part. So now N is 130 and P is 0.35. And we have to find the probability that it says at least 50. So this Y is greater than or equal to 50. So we have to find this at least 50. So guys, I'm telling you repeatedly that you have to be very careful with the equal mark whenever you are dealing with the binomial distribution. Okay? Now this is such a big number. We have to find this. So we'll have to use that normal approximation. So we need to bring in a normal distribution over here. Okay? So we would say, okay, I don't want to use Z here. Let me use another letter, let maybe P. Let P is normally distributed. Now I need to have the mu, okay? So the mu is, we know that is NP. We have to calculate it from here. Can someone please quickly tell me what is 130 times 0.35?
Sir, 45.5.
Thank you, Beta. 45.5. That is a mean. And then we need to have the variance as well, okay? That is NPQ. So the same times into 0.65 because we have got this NP with us times point, what is this? Times 0.65.
Sir, 29.575.
Yeah, 29.575. Okay, this is 29.575. So we have got that normal distribution through which we're going to get this bigger numbers probability here. Now we have to say, okay, look, this probability y is more than equal to 50, which was from the binomial distribution into the normal distribution. This would be the probability that this p is more than or equal to, you can use equal to the mark if you want. Okay. Now this is your 50 here. um, so this is 50, this is 49.5, this is 50.5. So it says more than, okay? When it says more than, so should I consider this rectangle or not when I have to consider more than this 50 area? Hmm? Should I consider
No,
this?
sir.
Yes, we have to, because there is an equal mark here. 50 is included, and this bar is representing your 50. So this would mean this is going to be greater than 49.5. If you make a mistake here, you will not be getting more than 3 marks from all of this working. So now we have got this from this normal distribution. We have made that continuity correction here. Okay, a discrete data converted into the continuous data, and this process is called managing that continuity error over here. Now we'll be standardizing this. Okay, when we standardize this, so this would become probability z is greater than or equal to 49.5 minus the mean, which is 45.5 over the standard deviation, that is a square root of 29.575. Okay, so let's calculate this. This is going to be 49.5 minus 45.5, and this is divided by the square root of 29.575. So we have 0.7355. So since there's a greater than sign, so I would be writing 1 minus phi of 0.736. Okay. So who would help me to find this 0.736? I think I'll have to go myself. 0.736 is here. Zero point 0.7, this is 3, and this is against the 6. So that is 0.7691. So is 1 minus 0.7691. Okay, I go back to the paper. So this is going to be the result here. It says 1 minus 0.7691, and this is going to give us 0.2309, and correct to three significant figures. This is 0.231. So this was a question of 5 marks, guys. So you move from a binomial to normal, you make that continuity error, you standardize this, and then you find the correct value, the value correctly from the table, while you are managing this mean and the variance through the binomial distribution formulas.